Hello students, welcome back. In this video, I'm going to solve a question based on the basic concepts of organic chemistry and the acidic and basic strength of some of the organic molecules. So let's get started. For the given question, you have to choose the correct statement or statements with the property given here and the relationship between the molecules mentioned. The first property is acidic strength. The given two molecules are carboxylic acids and they have same groups attached to the carbons. That means they are geometrical isomers. Since the identical groups are on the same side of the double bond, we can call this as cis and this will be a trans molecule. Students, I'm giving you an additional tip here. The trans-butanoic acid is also called as crotonic acid. This is quite important. You have to remember the name of this molecule for the exam point of view. So this is crotonic acid and the isomer of it is called as isocrotonic acid. Between these two molecules, isocrotonic acid is more acidic than crotonic acid. Why is it so? This is because of the steric hindrance in the molecule. What is causing steric hindrance here is the methyl group. Because the methyl is occupying the space here, it will weaken the bond between oxygen and hydrogen. Because it is taking up the space here, it is literally pushing this hydrogen away as this bond is weak so that this carboxylate can accommodate in this space. Therefore, the cis isomer is more acidic as compared to trans molecule. In case of trans, they're away from each other. That means what? There is no steric hindrance here. Hence, cis is more acidic than trans. You can also justify this by checking the pKa values. The pKa value for the isocrotonic acid is 4.44, whereas for the crotonic acid, it is 4.69. Lower the pKa value, higher is the acidic strength. Hence, this is a correct statement. Therefore, option A is correct. For option B, we need to verify the stability of the free radicals. At first, what are free radicals? Free radicals are the reaction intermediates formed during the course of the reaction by homolytic fission of the bond. That means what? They will have one electron. So it's an odd electron species. Around the carbon here, altogether there are 7 electrons. 2, 4, 6, 7. That means what? It is deficient of one electron. If it is deficient of one electron, we need electron donating groups. More the electron donating groups, more will be the stability of the free radical. Phenomena like resonance also stabilizes the free radical. More the double bonds, more the resonance, more will be the stability. Let's apply this for the given molecules. Here, the carbon is tertiary free radical. That means what? There are 3 electron donating groups. So, it is quite stable. What about here? It is also tertiary, just like the previous one. But upon that, we also have a possibility of resonance. That means what? It is giving more stability to the molecule. And what about here? We have 2 double bonds to stabilize this. That means what? More the double bond, more the stability. Hence, the order of stability given here is also correct. Therefore, B is also a right option. We have to identify the basic strength of the given two molecules. Both of them are nitrogen containing heterocyclic compounds. Both of them do have lone pair of electrons on the nitrogen like this. But the position of the nitrogens are different. Is this going to help us to know the basic strength of the compounds? Definitely yes. How so? The basic compounds are the one which accepts the proton easily. Upon that, if the formed conjugate acid is stabilized by hydrogen bonding, then it imparts extra stability to the molecule. Say in this case, when nitrogen donates its lone pair and it forms a conjugate acid like this, then the lone pair of electron present on nitrogen can exhibit hydrogen bonding with the hydrogen here. It is forming a cyclic structure. You see here, it is forming 1, 2, 3, 4, 5. A stable 5-membered cyclic structure, which we also can call this as chelation. So due to this chelation, the first molecule is more basic as compared to the second molecule. In second molecule, such chelation is not possible because nitrogen is away from this particular nitrogen. That is the reason this is also a correct option. For option D, we need to compare the acidic strength of the isomer cis trans. This is something similar to what we have done for option A. The cis isomer will be more acidic than trans due to the steric hindrance. Exact same phenomena. Therefore, option D is also correct. Hence, for this question, all the options A, B, C and D are the correct options. Thank you for watching this video and don't forget to subscribe the channel and to solve the question I have given at the end of the video.